Hello, we're going to continue with equation solving. Now we're going to focus on multiplication and division. So let's start back at the beginning, and we want to think, how would we solve for the value of the triangle? Once again, 9 times triangle equals 45, and 15 equals triangle divided by 6. I know that the first one right away, you'd be able to see it and go, 9 times 5 is 45. But I want you to think back, what would we have done to get that answer if it was more complex? We would have done 45 divided by 9 give us this triangle. 15 equals triangle over 6. Okay, that one's a little bit harder to kind of visualize. So this one you might need to think, what is, the opposite operation? And what would you do to solve it? You would be doing 15 times 6 gives you triangle. So we would be using this inverse operation once again as we're looking for the value of the triangle. You can see again, 9 times triangle equals 45. I would say triangle equals 45 divided by 9. And 15 equals triangle divided by 6. The inverse operation would be 15 times 6 gives me triangle. So the value of the triangle in the first one is 5. And the value of the triangle, the second one, is 90. Looking at this with our box, don't solve it. What is the inverse operation? Just identify it. 12 equals 7. Remember, parentheses attached to it means multiplication times box. So if it's multiplication, my brain should be going, oh, I need to be doing the inverse, which is division. 22 equals box divided by 10. Same idea. Remember, that's a division symbol, okay? Or you could have the regular division symbol, but I use this one because it's not as obvious in our brains. So, well, if it's box over 10 or divided by 10, my brain should be thinking my inverse is multiplication. Now, moving away from our elementary brain, and we just replace now into our algebraic minds, we're replacing this box with x's. Okay, so 12 equals 7x. My inverse would be 12 divided by 7 gives me x. And then 22 equals x over 10. My inverse would be multiplication. 22 times 10 equals x. Next, let's take a look here. Let's tell the story again. Once upon a time, we had an algebraic equation. It was 11x equals 55. My brain should go, okay, pause for a second on my brain and go, I need to identify the inverse operation. Well, on the left-hand side of the equation, I'm looking at a multiplication problem, so the inverse operation is division. Once again, I know most of you can give me that value of x, but we need to show our supporting details. We need to have the details of the story. And the details of the story is x equals 55 divided by 11. Yes, it needs to be written. That story needs to be told. The conclusion of that story is x equals 5. If I now substitute the 5 in for the x and I say, does 11 times 5 give me 55? And if the answer is yes, that means you solved the problem correctly. If we look at 16 equals 32x, once again, that is my once upon a time. My inverse operation, 32x, means multiplication. So my brain goes, I need to tell the story of division. The story of division is 16 divided by 32 is x. I could write it with the division symbol, or I could write it in fractional form. Now, at this point, you might be, I don't know what 16 divided by 32 is. Well, guess what? What if we simplified 16 over 32? Oh, I get a half. I could leave it as a fraction. I could say half, or if I wanted decimals, if I did long division, I would get 0.5. So don't always think that you need to do long division or grab a calculator. A lot of times in algebra, you're going to see things in fraction form. If we go on to the next situation, x divided by 9 equals 13. So again, once upon a time, x divided by 9 equals 13. Okay, well, if I said divided and I'm thinking inverse, the opposite of division is multiplication. Now here come my supporting details. X equals 13 times 9. That's how I'm going to solve it inversely. When I multiply 13 times 9, I get 117. So I ask myself, does 117 divided by 9 give me 13? The answer is yes, so I know I solved for the value of x correctly. 112 equals x divided by 4. Okay, so again, a division problem. So my inverse operation is multiplication. Show how you would find the value of x. So again, here is my supporting details. I need to multiply 112 times 4. Now at this point, I might need to go off to the side on scratch paper to figure out what 112 times 4 is. Okay, and then once you do that, you're going to find that it's 448. Now this is going to look exactly like your practice sheets with one change. I did put an area to the right that we'll have for scratch work. So the equation 6a equals 42. I think that's multiplication, so I do the inverse operation, which is division. A equals 42 divided by 6 goes in the inverse equation, and then I simplify my solution at a equals 7. Next example, 13 equals x divided by 7. Okay, so I have division, so therefore I'm going to multiply as my inverse operation. X equals 13 times 7, and x equals 91. So at this point, I would like you to pause the video so you can have this up on your screen, and you're going to go to your lab sheets, and you're going to continue with lab sheets solving multiplication and division. I believe there's 2 or 3 of them that you're going to be working on.